These are going to be the notes for section 8.1, the Pythagorean Theorem and its converse. The objectives are I will be able to use the Pythagorean Theorem and I will be able to use the converse of the Pythagorean Theorem. We've already talked a lot about the Pythagorean Theorem in terms of the distance formula, and you should have seen it earlier on in 8th grade math or pre-algebra. So the Pythagorean Theorem is a squared plus b squared is equal to c squared. Or a better way of writing it would be one leg squared plus another leg squared is equal to the hypotenuse squared. If we want to write that out in words, we say in a right triangle, the sum of the squares of the measure of the legs equals the square of the measure of the hypotenuse. So as you can see on our picture, we have A and B as the legs and C as the hypotenuse. So we're just going to use the Pythagorean theorem. We're going to find the value of x, and we're going to put our answer in simplest radical form and approximate it to the nearest hundredth. So we have the Pythagorean theorem for all of these. They're all right triangles. These only work on right triangles. The name of this unit is right triangles. So the legs are 9 squared plus x squared, and the hypotenuse, again, is c. That's going to be 15 squared. So what we do is we take the squares of all of these. 9 squared is 81 plus x squared, and that's going to equal 225. That's 15 squared. And then we just subtract 81. It's always a good idea to check your work with the calculator. 225 minus 81 is 144. So we get x squared is equal to 144. And you should remember the inverse of a square is the square root. So x is equal to 12. So that answer is in simplest radical form, and we also approximated it to the nearest hundredth because there's no ongoing decimal. Let's go down to number 4. Number 4 might be a little bit tricky, but you should see the right triangle in this shape. So what I'm outlining in black is the right triangle. So again, it's a right triangle, a squared plus b squared equals c squared, the Pythagorean theorem. C is always the largest side. It's across from the right angle, so that means C is 28 squared. And my legs are just 11 squared plus x squared. So whenever I take the squares, I get 121 plus x squared. And we have 28 squared. Remember, it's that button that's right here. That equals 784. We subtract 121 from each side. We get 663. To get rid of the square, we take the square root. So the square root of 663, this is a number that won't stop. So we round it to the hundredth. That's the second decimal point. So x is about equal to 25.7. We bump up that 4 to 5. If I want to find out what the square root of 663 is in terms of simplest form, that's kind of a tricky one. And y equals, probably the easiest thing you can do is 663 divided by x squared. So if you want to break up a square root, you can do this. And if I go to second, so again, second, that's the button in the top here, and I hit graph, I'll get the table. If I have any whole numbers in y1, that means it can be simplified. And going down, I see I don't have any whole numbers. So that means it's already in simplest form. So x is about equal to 25.75, and it's actually equal to the square root of 663. We can't break that square root up anymore. So what I'd like you to do is try numbers 2 and 3 on your own. Number 2 is a little bit different, but I know you can do it. B is a leg, which is what we're solving for, and we already have the hypotenuse. So it's a little bit different, but just keep using the equation, it'll be easier. A Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So the most famous Pythagorean triple is 3 squared plus 4 squared is equal to 5 squared. You'll see these numbers that work. A lot of times we don't have them, like 1128 and the square root of 663, but they do pop up. Number 1 was a Pythagorean triple because we had 9, 12, and 15. That was another one. So 9 squared plus 12 squared is equal to 15 squared. So just keep those in mind. Another big idea is the converse of the Pythagorean theorem. So remember that word converse. That means we change the order or flip it from unit 1. This time it says if the sum of the squares of the measures of legs of a triangle equals the measure of the square of the measure of the hypotenuse, then the triangle is a right triangle. So this is nearly the same as the Pythagorean theorem. It's just the converse. We flip it. So for our example, it says determine which triangles with the listed side measures are right triangles. So we're just going to use the Pythagorean theorem. So we'll try the first one. Does 18 squared plus 24 squared equal 30 squared? This is a very simple problem in the calculator. 18 squared plus 24 squared equals 900, and 30 squared is 900. So this is a right triangle. It's also a Pythagorean triple. We have 3 whole numbers. Let's try this one beneath here. 26 is the biggest number, so that's going to be C. So we have 10 squared plus 17 squared. Does that equal 26 squared? So the left side's equal to 389, and the other side's equal to 676. So 389 does not equal 676, so this is not a right triangle. So if they're equal, they are a right triangle. If they're not a right triangle. So what I would like you to do is try these 4. We also have a couple word problems. So number 11 says find the length of the missing side and the area of the triangle. So it's a little confusing here on what the missing side is. So the missing side is this whole piece here, x. It's also the base. So if I want to do that, I can break this up into Pythagorean theorem problem. I can find the missing bottom part of the red. So I have a squared plus b squared is equal to c squared. A and b are the legs, so I have 10.8 squared plus some number, we'll call it y squared, or we'll just keep b actually, that'd probably be easier. Well, we might run into trouble later, so we'll keep it as y, equals 12 squared. $10.8 squared is that much, and 12 squared. So we have 116.64 plus y squared is equal to 144. Subtract 116.64. We get 27.36. And we just take the square root. So again, second, that button there, the x squared button. So we get about 5.2. So that means that this is 5.2. And the other side you should see is also 5.2. They're both equal. These are congruent triangles. You should know they're congruent by hypotenuse leg. That's a nice little review. We have the hypotenuse and one congruent leg. So the red and the blue triangles have to be congruent. So now I found the missing side. Actually, I have one more step. 5.2 plus 5.2 is 10.4, and these are meters. That's our unit. And to find the area, that's going to be 1/2 base times height. So it's 1/2 the base. That's what the missing side is. It's going to be 10.4 times the height. That's 10.8. So alpha y equals enter. 1/2 times 10.4 times 10.8. And we get 56.16 meters squared. So I'd like you to try number 12 on your own. And if you have any questions, please come to class prepared. But again, this should be a review from everything we've been doing all year.